Okay. Come on. All right. All right. I will begin with a word of prayer. Ahem. 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 All right. Dear Father, we thank you for this day. Again, I thank you for most of these students. And I pray that you be with us today. Help us to glorify you what we do and just to learn a little bit about what a function is, Lord. In your name I pray, Lord Jesus. Amen. Let's see here. So, I'm just kidding. I like all of you. Let's see here. Now, oh, man.
What's your favorite class? Or we like your second?
You guys are my favorite section of college algebra this semester.
That's horrible.
What's that? Am I only teaching one section of college algebra? Yeah, that's true. Yeah, that's also true. So I guess of all my college algebra sections this semester, you guys are the worst. That's also true. Yes? I have a request for a problem I just put on the quiz to see the solution of it. That is, yeah, it's the top hat. It's top hat. Okay. Which problem do you want me to see? Which problem do you want me to solve?
Number 3.
Number 3. So quiz number 3. We had x squared minus 1 over x squared plus 3x plus 2 times x plus 2 over x minus 1. All right. And so what I did was we're supposed to multiply or simplify or both. So x plus 1 times x minus 1 times x plus 2. Does the denominator factor? Indeed it does. This is x plus 1 times x plus 2 times x minus 1. And so, what is the story here? How's it go? So you got this cancels that, and you got this one cancels that, and you got this one cancels that. And so what we're left with is 1. Oh man, right?
No, I put everything canceled, but then...
You put 0?
No, I put everything canceled with my time.
Oh, but you didn't write the 1. All right, well,
Start off class. Can you show me how to complete the square and then throw a marker at me as hard as you can?
okay. So I'm supposed to throw a marker at the computer? Is that it? Let's see here. Interesting. All right, so let's see here. I will move on. What's that? Question number 4. Yeah, we can go over question number 4. But after this, I'm going on to the new material. Okay, so quiz number 4. Here we had 2x plus 1 over 3x minus 1 equals to x over x plus 4, right? And so we're supposed to solve supposed to solve this. So I would cross multiply and multiply it out. So x plus 8 plus 9x plus 4, 3x squared minus x. So I've got 3x squared minus x minus 2x squared minus 9x minus 4 equal to 0. I moved everything to the right-hand side, and I flipped the script. So we've got x squared minus 10x, x squared minus 10x minus 4 equals to 0. Now that does not factor nicely, but we can complete the square. X minus 5 squared minus 25 minus 4, which gives me x minus 5 squared equals to 29. So x minus 5 is equal to plus or minus the square root of 29, which is x is equal to 5 plus or minus the square root of 29. So that was that one. So, yep, that was that. Okay, so let me move on here. Today we're talking about functions, right? What's a function? Yes?
Function is like if you have like an x, which is equal to 2, and then like 2, and then you have the x, which is equal to 2, then the y would equal to 4.
So,
You have one job. Like,
sorry, Beth Ann, I was distracted. So you said what was your f of x was what?
it was 2, so
It was 2. So your f of x was 2?
yeah.
Just like that? I mean, this is a function. Like this would be a constant function, right? I think you were saying 2x though.
That, like, yeah.
Like 2x. Then if you plug in 2, you get 2 times 2, which is 4.
Yeah.
So like there needs to be like way less talking in here going forward today, okay? Because I cannot lecture while you guys are talking. It doesn't work for me. I have trouble with my own thoughts. I can only deal with my own thoughts at once. So not also yours. Yes.
Media team question?
Uh-oh. Uh-oh. Oh no. Immediate. Yeah, I'll fix that. So this stupid mic. Oh, wait a minute. No, that's worse. Yeah, that happens. It's okay.
So it feels like the battery pack's gonna fall. I don't know.
Oh no, that's just how it is. It's all good. There we go.
Much better.
Here we go. Wait.
It's too wound up. We gotta go once around.
There you go. All right. So okay. So what is a function? Now Emily is me. Beth Ann rather, has given me a kind of an answer, which is there's a formula, right? And that's possible, right? We could define a function with a formula. That's true. But I would say generically speaking, we could think of a function something like this. A function, I think of it as sort of a machine, and you take x, you put x into the machine, right? And what comes back out is f of x, right? So it takes an input and it makes an output, right? The input is x, the output's f of x. You could think of it this way, all right? You can also kind of draw a picture. You could say f is something like here's A, here's B, and f is something that goes from A to B like this, right? It's a mapping from one set to another. It takes an input here, and it makes an output over here like that. So here x is an element of A, whereas f of x would be an element of B. All right. The inputs to the function we call the domain of the function. So this is the domain. And the outputs in this context we'll call the range. All right. Input is the domain, output is the range. All right. Now I've drawn this function very sort of abstractly at the moment. Right? You could talk about a function of chickens, you know, like what would a function of chickens be like on a day, like, I don't know, over a year? Or you could talk about input a chicken, how many eggs does it lay, right? That would be a function, right? The number of eggs that it lays could be the output. So there, you know, the domain would be a set of chickens, and the range would be real numbers. Well, actually just counting numbers, right? No chicken lays half of an egg. So, you know, counting numbers would suffice. But usually for us in here, we're looking at functions of a real variable. So if you have a function which goes, and so here's other notation. This means function from A to B. So this is the domain. And over here is, well, technically it's the codomain. But we'll just call it the range because we're not really going to worry about the distinction between codomain and range in here. Just saying, there is something to think about there in future courses. So now here, both A and B are going to be subsets of the real numbers. All right, subsets of the real numbers. So to define a function, we really have mostly just two choices in here, all right? Now your book talks about a second, a third, and a fourth choice, but I really don't care so much about those. All right? So the two choices which are of primary relevance to us are either we can give a formula or we can give a graph. You could either define a function by a formula or a graph. All right? So number one, so you're like basically given f of x is some formula, equals some formula. That's the one way. Oftentimes that's the way we do it. Some formula in x is what I'm talking about. So just to further elaborate on that point, let me just list a couple of examples right here before I go on to my next point. Like example 1, you could have f of x equal to 3x plus 2. Example 2, you could have f of x equals to x squared plus 1. Example 3, we could have f of x equal to the square root of x. These are formulas, all right? So in the context of when you're given a formula to define a function, we have a custom in here, right? Which is that we make the domain as greedily as possible, all right? So like the domain, by implicit assumption, is going to be the largest set of real numbers which works. So you guys tell me, what's the domain for my example 1? We've really thought about this idea already when we talked about, I talked about the domain of a rational expression, right? I really was talking about the domain of a rational function. So it's that idea, it's the same idea as that, not a different idea. So which x is that a real number for? Like if you take 3 times a real number, add another, add twice, add 2 to it, it's still real, right? So the domain here is just everything. That's kind of boring. How about this one? Again, what's the domain? It's everything, right? If I want a real output, what's my domain? What do I need for example 3 though? I need what? I need the input to be greater than or equal to 0, right? for the output of that function to be a real number, right? So if I want the output to be a real number, I need to input either a 0 or a positive number. So in this case, the domain of f, it's a little bit more interesting. It's just 0 to infinity. Right. So to figure out the domain from a formula, you just have to think about the formula and ask yourself the question, what x does the formula make sense for? All right. Now there's another way that this can happen. Sometimes you're given a formula with strings attached, right? You could be given a formula and then you're just told what the domain is. You know, that's another possibility. So this is kind of one, let's say one part 2. You can be given f of x subject, some condition. So for example, you could have something like f of x equals to x squared plus 1, where minus 1 is less than or equal to x is less than 2. If that's the case, if they tell you that, well then that's telling you what the domain is. The domain in this context would be what? We got minus 1 all the way over to 2, 2 not included. That would be the domain, right? So you can take a function and you can make the domain smaller if you want. Like that's a freedom that we have conceptually. All right, so that's the one way. We can give a formula. The other way to define a function is by its graph. All right, by its graph. So what's a graph of a function? So definition, if f is function on the real numbers, that's just a fancy way of saying that its domain and its range are both subsets of real numbers, okay? That's what we're looking at in this course, though, is functions of a real number. Functions on R. Okay, then, what's the graph of f defined by? Then the graph of f is equal to the set of ordered pairs such that what? Such that x is in the domain and y is equal to f of x. Put more simply, the graph of f is x comma y such that is all x comma y such that y equals f of x. So what I'm saying is that the graph is a subset of the xy plane, right? The graph is a subset of the xy plane. And so if you work this backwards, what this means is if I give you a graph, you can tell me for that function lots of information about it. So like example 4, see if I give you this graph here, like that, and I say that this is y equals f of x. I'm giving us the graph y equals f of x, and this point right here, let's say that this point is minus 4 comma 1, and this point over here is, 4 comma 5, all right? So this is the graph of a function, all right? If I give this to you, that serves to define the function, all right? Because what it does for you is it tells you the relation between, x and y. So let's suppose, for the sake of, imagine that we had a grid on here, and you could see that this y-intercept was at 2, right? So since this is the graph of a function, we can read from this a couple different things. So here's 3 different things you can fill in the blanks for me. F of minus 4 is equal to what? F of 0 is equal to what? F of 4 is equal to what? So f of minus 4, because this is the graph of the function, remember y is equal to f of x. So that means that this pair, minus 4 comma 1, right? Minus 4 comma 1 has to be equal to minus 4 comma f of minus 4. Since it's on the graph, the y component, the y coordinate, has to be related to the x coordinate. It's f of the x coordinate. So from this, I read that f of minus 4 is nothing but 1. And this point right here, right? What point is that? If I write it out, this is the point 0, 2, right? Since it's on the graph, that's 0 comma f of 0. The only way for that to be true is for 2 to be equal to f of 0. So f of 0 is 2. All right? What is f of 4 equal to? 5, right. Once you get the hang of this, it's not that hard, is it? Let's see here. So, what's the formula for f of x in my example 4? The answer to that question is, that's an unreasonable question. Stop that, right? Like, you don't have to come up with a formula necessarily. Sometimes we can describe a function by its graph, all right? What are the other 2 ways you can define a function according to the book if you've read it? They like to give little dot diagrams. So you like draw dots that represent a set of numbers for the domain, another set of dots that represent numbers for the domain, and then you just draw lines from one pair of dots to one set of dots to the other, and the lines indicate the mapping of the function. That's the other way, these dot diagrams. Still another way is you can just explicitly give it as, you can just write out the graph of a function as a list of ordered pairs. But in my personal opinion, the dot diagrams and the list of ordered pair example, while I think it's interesting for math majors, I don't think it's interesting for you guys because it only exists at the start of the function discussion, and it always confuses you guys to no end, so I just decided to try to not talk about it. So let me stop talking as to not go across my purposes. So either a formula or a graph, all right? Are we good? Now, what's the domain of my example 4? What's the range of my example 4 function? The domain of f equals all x values in graph. Range equals to all y values attained in graph. So you guys tell me, we're going to use that dreaded interval notation. So what's the domain here?
It would be
Negative 4 to 4. Are they included or excluded?
-4.
Included. And the reason for that is I made these solid dots. All right. If I make an open dot, that means it's excluded. What's the range? 1 to 5, right? Yeah, 1 to 5, both included again. For reasons I don't understand, college algebra has a lot of problems with this problem on the test. Let me do another, slowly. So maybe if I put this one on the test, everybody get it right? But what I usually put on the test is a little bit more interesting. So let me show you one that's kind of a typical test question on this material. By the way, the concept of a function as a mapping is a relatively new concept. In fact, really, I would say that professional mathematicians have really only embraced this idea fully in maybe the last 150 years or so. Before that, really the concept of a function and an equation were very much muddled. But anyway, so here's another example. Let's suppose you're given the graph. It starts here, goes up to here. I'll put an open circle right there. And then we go down here, and then we'll go over to here. And again, I'll put an open circle here, closed circle here. Let me give some points. Let's suppose that point is minus, oh, and here I'm going to, fine. Rats. Well, I'll put the open circle over here. That's what I wanted to do. My bad. I'll fix it. All right, there we go. So let's say the starting point here is at minus 1, 0. This point up here, let's say, is at 1, 0. Excuse me, 0, 1. My bad. This point down here is at 1, minus 3. And here we've got minus, we've got, let's say, 8, minus 1. And then I tell you that what we're looking at, right? What we're looking at is the graph of a function. By the way, we should really talk more about when can you decide a given curve in the plane is not the graph of a function. Something I have not emphasized enough yet is that a function has to be, that machine picture I drew a second ago, it just, just one thing comes out. You put in x, you get back out f of x. F of x is a single thing, it's not two things, all right? So a function has to be single valued. It has to output one thing. But we'll talk more about that after we're done with this one here. So you guys tell me. What can you tell me about that is my question. What would the domain be this time?
Including negative 1.
Uh-huh.
Not including 0.
Not include 0, okay.
1, 2.
And then,
Including 1.
then I do like union, right? Union with 1 included,
1 included to 8, 9.
8 not included. Very good. That is correct. That would be the domain here. Those are all the x values that we see on the graph. All right? What's the range here? Again, the range should be the y values that are attained on the graph. So the range, so the way to figure out the range is you just kind of have to look at the graph and imagine hitting it with horizontal lines like this. You guys see me? You kind of just look at it top to bottom. Where's your first y? What's the lowest value of y? Negative 3. That's where we start. It's included because the dot is closed, right? So minus 3. And we keep getting y values, right? Up to here. So we don't include minus 1. And then it picks up again here at the x-axis, right? Our next y value that we attain is 0. So we include 0. And we go all the way up here to 1, but yeah, 1's not included, right? So what else? Yes.
What's the difference between the included and not included?
So the circle means that point's not actually part of the graph. It's like an open dot, whereas the closed dot means that point's actually in the graph. It's included. Yeah.
And if it's included, we do the square.
Right. Yeah. If it's included, then we include it in the interval by writing the square bracket. All right. So let me ask some additional questions here. Some additional questions. All right. So try us out here. F of minus 1 equals fill in the blank. F of 0 equals fill in the blank. F of 1 equals fill in the blank. F of 8 equals, let's fill in the blank. So what do we got here? How about f of minus 1? What's that equal to? 0. Now, for those of you who answered, how did you know that? You looked at this point right here, right? And since it's on the graph, this has the form minus 1 comma f of minus 1, right? And then this has to match that, which tells me that f of minus 1 indeed is 0. How about f of 0?
No solution.
No solution. Very good. So we usually write does not exist in this case, because 0 is not in the domain of the function. In other words, that's an unreasonable question, right? Like, I don't know, you meet somebody, maybe you're going to start dating them, you tell them at the start of the relationship, I just have one rule, we can never eat at Bojangles, right? And then they say, you're like, where do you want to go to supper tonight? And they're like, let's go to Bojangles. You'd be like, mm-mm. Bojangles does not exist. It's not in the domain. That's how this works. So, that's fair. My pastor's all about some Bojangles. Like, if pastors start talking about eating, I know like the end of the sentence, it's going to be Bojangles. It's like almost a law. So f of 1, oh, I have made a tactical error. I gave you an excuse to talk about anything other than math in a math lecture. You'd think I would have learned by now. So here, f of 1 is what? -3, right? And f of 8 does not exist. There we go. All right, so, all right. This conversation with you guys has given me hope that when I ask a question like this on the next test, you're going to, you're all going to get it correctly. Hey, if everybody in here makes an A on the next test, I'll bring Bojangles to class. I have again made a tactical error. All right, guys. Back here. Back. Come back to me. So my question is, going back to my example 1, example 2, and example 3, we figured out the domain, right? Wonderful. How do you figure out the range? If you're given a formula, how do you figure out the range? What's that? You do what? Did I hear plot it? I mean, that's not a bad answer if you said plot it. Okay. See, that would have been more meaningful after I... But you see, we've already talked about plotting these, because we've talked about how to graph these equations, have we not? This is a line. Y equals 3x plus 2 is a line. Y-intercept 2, slope 3. It looks like this, right? I mean, there it is. So given that, what's the range of f? Negative infinity to positive infinity. Very good. Yep. This is a parabola. We talked about how to graph those too, right? This is a parabola. Where's its vertex? It's at 1, right? 0, 1, and it opens upward. It looks like that, right? This is y equals x squared plus 1. What's the range in this case? You could write range of x squared plus 1 if you like. What's that? 1 to infinity. Included or excluded? Included. Very good. Yep. So there you go. What does the graph of the square root of x look like? I don't know if we've talked about this or not yet before. So let me talk about it. Let me take my time and talk about it a little bit. If you look at y equals to the square root of x, right? You want to understand how to graph that. The way I like to think about this is to square both sides. We get y squared equals to x, right? So it's really x equals to y squared. I mean, that's what y equals the square root of x is. It's x equals y squared. What is that? Think about it. It's a parabola where the role of x and y has been reversed, right? So that's why the graph of the square root of x, it's basically a parabola turned sideways, right? Now that's not true yet. Hold on a second here. The square root is by definition what? Remember, the square root of x is by definition greater than or equal to 0, right? So this actually is not part of the graph, right? This is this piece down here. This piece down here is part of the solution set of this equation, right? The graph of the square root of x is just this piece right here. Does So there you go. That's y equals the square root of x. What's the lower piece, the graph of? That is exactly it. It is y equals negative the square root of x. That's what it is. So that's part of a larger discussion that will continue another day. But there it is. Y equals minus the square root of x. See, because if you take this equation right here, right? If you take that equation and you solve it, when you solve it, what do you get? X equals to what? I mean, excuse me, y equal to what? Plus or minus the square root of x, right? If I solve that, I get y is plus or minus the square root of x. So the graph you have here and you have there. Now going back to my example, what's the domain of what's the range of the square root of x? I should have done it in blue. Sorry about that. So what are the y values of this half parabola? 0 to infinity. Yep, you guys got it. So, yep, for example 3. We good? All right, so is everything a function? Like, is the graph of, is everything a function? Have we looked at anything where you're actually not looking at the graph of a function? So let me just talk about something here. Let's talk about the vertical line test. All right, so suppose you've got, f of x comma y equals to 0. So this is like some equation. All right, some equation in x and y, right? And you look at that and, I don't know, maybe the equation graphs to some kind of weirdo thing like this. You can come up with equations to make pretty much any shape you want. You just play around with the equations long enough, you can come up with anything, practically. The question then is this actually the graph of a function and describe, can you look at this as the graph of a function? Is this the graph of a function? Why not?
Because you're going across it, like with a line, it's hitting 2 points of it.
Ah, very good. So like if I look at this line right here, right, this vertical line, what happens? We've got 1, 2, 3, in fact 4 different points, right? So we'd have to have f of, let's call that, let's say that this is happening at 4, and let's say that these points are respectively, 1, 2, 4, and 6. Yeah? So if these 4 points are on this graph, that would mean that f of 4 is equal to 1, and it's also equal to 2, and it's also equal to 4, and it's also equal to 6. In other words, that one input of 4 would output 1, 2, 3, 4 outputs. But this violates the definition of function, right? Function can only output one thing. So the vertical line test is simply this. If you're looking at the graph of some equation, all right, and it goes through, a vertical line cuts through the graph more than one point, then you're not looking at the graph of a function. Here's a more simple example. 5, is it? Right? If I'm looking at this shape, right? A circle, is this the graph of a function? Well, the answer is no, because it fails the vertical line test. So you got these 2 y values for a single x value. So this is another kind of question we like to ask you guys. Here's the graph of some equation. Could this potentially be the graph of some function? And the answer in the answer to this one is no. Another way to ask this, though, is this. So here's the other way this comes at you. Example 6. Suppose x squared plus y squared plus 10y is equal to 0. Can we express this graph, well, excuse me, can we express the solution set of this equation as a graph y equals f of x for some f? That's another question that we often can find ourselves facing. All right? So how would we address this question? If you don't mind, I'm going to erase my weird picture. So the answer to this kind of question is it's pretty simple. What you have to do is you have to try to solve for y. If you can solve for y and give it a unique value, then yeah, it's the graph of a function, and it's whatever function you found, right? So like, how do I solve that for y? So we want to solve x squared plus y squared plus 10y equals to 0 for y. How do you do that? Yep. Pull out y. I think that's the right kind of idea. So I'm going to take your suggestion and say move x's to the other side, right? And then, so how would you pull out y here, though? See, if I pull out y, then I'd have y times y plus 10. So I'd have a y in both of those things. That doesn't quite help me. You have a square, so we would do what? We would complete the square, right? Yeah. So this is y plus 5 squared minus 25 equals to minus x squared. In other words, y plus 5 quantity squared is equal to 25 minus x squared. So y plus 5 is plus or minus the square root of 25 minus x squared. So we get y is minus 5 plus or minus the square root of 25 minus x squared. So is this the graph of a function? The answer is no, because we couldn't find just one formula. We had to find two. The plus and the minus, right? They're both there. And in fact, this example 6 is really just the same as example 5, right? Because after I complete the square here, if I just take a hop, a skip, and a jump, I could rewrite this as what? X squared plus y plus 5 quantity squared equals to 25. And you should recognize that what we're looking at here is nothing more than the circle with center 0, minus 5 with radius 5. Namely, it's this circle. So does that circle fail the vertical line test? Oh yeah, sure does. What is the significance of the plus and minus solutions that we just found? Yeah? But you can ask your question. I'll come back to mine.
So is it always going to fail the vertical line test if you have the y squared? Because that means it's going to be either like a sideways parabola or a circle, right?
Well, not necessarily. I mean, it depends on how you come at it, you know? I mean, you can add terms and conditions here, right? Like here we had y squared equals to x, but there was a string attached, right? The string attached was that y is greater than or equal to 0. So sometimes you have like a subsidiary condition which rules out the duplicity which is in the algebra, like that could happen. But as a general rule of thumb, yeah, y squared is worrisome.
Also, what does duplicity mean?
Like more than two things. Think like a politician. They're duplicitous. Yeah. There's a politician in Convo. Oh, I'm sorry. Who? Which one was it? Who?
Attorney General.
Attorney General. Oh, so a future gubernatorial candidate for Virginia, then probably. What's that?
There was like Jason VR.
Jason BR? Oh, okay. Oh, yeah, I saw his picture on the splash page or whatever. Yeah. Yeah. So he said we should abolish abortion in the state of Virginia, right? No exceptions. Murder should be murder. Is that what he said?
He just talked about like America.
Oh, okay.
Be kind, better than
Be kind.
Don't be polarized. And then that was kind of it.
Don't be polarizing.
Yeah, don't be polarized. Like don't.
So don't oppose people who are openly like advocating for child abuse in the public square. Don't be polarizing. Because that's like what we're up against at the moment.
Advocate for child abuse in public square.
About 40% of the population is. Yeah. Yeah.
I mean, yeah, abortion.
No, not that. The other thing. So the other thing that if I talk about here in the video I'm about to post on YouTube, it would be problematic for me. Yeah. Right? Yeah. Yeah, nobody's watching this. All right, so okay, so my point though was the plus and the minus means that, well, it means you can't solve for a single y, right? And of course, if we just graph this equation, you can also just go back and say vertical line test, we fail, right? So logically, even if you can't solve for y, if you could graph it and see that it fails the vertical line test, it would also prove it's not a function, right? What is the plus and minus though? It's interesting. The plus is the top half, right? This is the plus. That's y equals minus 5 plus the square root of 25 minus x squared. I mean, I would say that I think changing a person's biology irrevocably before they're the age where they can think, to me, that falls under the banner of child abuse. So, you know. All right, sorry, getting back to math. Y equals to minus 5 minus the square root of 25 minus x squared. That's the lower half, right? So the algebra actually gives you the upper and lower half. Now, so for a circle, it's the graph of two functions. That's true. If you take the union of those two graphs, you get the whole circle. Yeah? And, well, this is part of a more complicated and difficult story that we can only answer totally with calculus. But it is true for most like equations, if you just focus your attention on one point, you can graph the curve near that point as the graph of a function. So like locally, you can solve for y as a function of x. It's just globally, you usually need more than one. So, so don't be polarizing. That was the message? Oh, okay.
Like
Be kind, be loving. I mean, in context, sure. But, you know, the state is the instrument of God's wrath. So I don't like my politicians to just be kind, as a general rule. But that's me.
And then the guy came and talked for CampCon about getting sugar from his wife.
For what?
Oh, yeah.
For what?
Can't. About getting sugar from his wife.
But he also talked about men actually asking girls out instead of guys,
Talked
so-
about getting sugar from his wife, like for cough, for like, for...
It's not about to get sugar 24/7 and
Yeah.
No one wants to hear that. Like, it's like, good grief. And like, especially like people who are not married and like maybe people who are not having success finding a mate. Like, you don't want to hear this nonsense, right? Anyway.
I'm single for those.
Oh, the Clayton, you said it was Clayton. Okay. What are we? Example 7. All right, let me do some simpler things. Let's talk about evaluating a function. Evaluation of function. A lot of times this is what you guys need to do. So given formula f of x, set x equals to stuff. Work it out. So example 7, let us suppose that we have a function. And here, let me work with one I don't want to graph. Here, I definitely don't want to graph this in here at the moment. F of x equals to, let's say, x cubed plus 1 over the cube root of cube root of x plus 1. All right, here's a function. Kind of an ugly one. All right, let's look at what is f of 0. What's that equal to? What does that mean? F of 0. So first of all, you have to watch out for this. You guys have been conditioned sometimes to think of this as meaning multiplication by 0, right? But that's not what this means here. This means we're plugging 0 into the function. This is function evaluation, all right? So that means we're taking the formula and we're putting x to 0. So we do 0 cubed plus 1 over the cube root of 0 plus 1. What do you got? This is 0 plus 1 over the cube root of 1. What's the cube root of 1? 1, right? So this is 1. Let's try something else. What if I said, what is f of x plus h? What would that be equal to? So I heard x plus h cubed plus 1 over the cube root of x plus h plus 1. That would be correct. So listen, so for this one, I find sometimes for problems like this, it's helpful to take the given one and the given formula and rewrite it in terms of a different letter. So let's say u. F of u is u cubed plus 1 over the cube root of u plus 1. See, if I do that, then I can think about, to get down to this answer, right? To get down to this answer, I do what? I just put u equal to x plus h, and then we can see where that came from. It's just a substitution, is all it is. Beth Ann, did that answer your question? Or, are we good? Should I do more of these? Okay, let me do another. That's it, yeah. There are other problems where you're asked to simplify this kind of thing. You know, like example 8 could be something like, I don't know, f of x equals to 1 over x, and then simplify f of a plus h minus f of a. That's a kind of typical question. Sorry, I didn't bring my physical attendance sheet. We'll have to take a 2 for next time. I just was excited that I remembered to bring your quiz back, which is like, you know, you have to take, that was a victory for me. What's that? Little victories, yes, yes. So, yep.
I tried integrating topics, but it didn't let me put it in.
Oh, I wouldn't worry about it. I mean, I will take attendance. Did it not? That's weird. Well, it closed itself. I don't know why it closed itself, but maybe it's because I closed it. You know, that's probably it. That's probably it. Don't worry about it. Oh, I shouldn't shut this. Okay, so this one here. So what is this? F of a plus h minus f of a. What is that equal to? Well, f of a plus h is what? 1 over, we put x equal to a plus h, right? And f of a is what? Just put x equals to a. So that's that, right? And then the question was to simplify this. How would you simplify a difference of fractions? What do? Make a common denominator, right? So we do a minus parentheses a plus h divided by a plus h times a. So I multiply the first one by a over a, and I multiply the second one by a plus h over a plus h, right, to make this common denominator. Does that simplify? I think it does, right? That's minus h over a times a plus h. I mean, you can leave it like that. There you go. So,
How'd you get like, oh, did you just subtract?
yeah, I just canceled the a's and distributed the minus. That's that. Yeah. Should we work another? Do another here. Example 9. Suppose you've got f of x equals to x squared plus x cubed plus x to the 4th plus 1. Let's calculate f of 2. And let's calculate f of minus 2.
2 to the 2nd power plus 2 to the 3rd power plus 2 to the 4th power equals 2.
Right? Which is what? What's 2? That's 4 plus 8 plus 4 plus 8 plus 16.
I'm really bad at addition.
You're bad at addition. 20, yeah. So 29 has come back to us again. What's the difference when you plug in minus 2?
It's the same.
It's the same but different. Different how? When we have a negative number to an odd power, we get a minus. If we have a negative number to an even power, we get plus, right?
So 4 minus 8 plus 16.
Yeah, so yeah, you said 4 minus 8 plus 16 and plus 1.
12, 13.
It's 21.
I've got 1 vote for 21, 1 vote for 13.
Negative 4 plus 16 is 12.
Yeah, 13. So it's 21 minus 8, right?
Oh,
Yeah, you missed the 8. It's all good. All right. Can you guys do? You guys can do this, right? This material's taking candy from the proverbial baby. That really only makes sense if the baby's sleeping, though. Should be noted. All right, let's look at some problems in the homework and see if we can understand them. There's something else that I haven't talked about yet, which tends to give you guys fits. Come back to me. No, this is just the recommended homework. So, what's that? It's in the course planner. I hid the course planner in an announcement at the start of the course. So, but let me just talk about some of these problems, you guys. How about this one? So A, what is f of minus 2 for this one? What would f of minus 2 be for this?
0.
0, yes. What would f of 4 be for this one?
It would be
Yes, f of 4 would be equal to 4 here, I believe. Or possibly, yeah, that's 4. All right, great. The other thing I haven't mentioned yet today that I should just talk about, this is not a hard thing, but I think you guys will get it. We can talk about functions increasing and decreasing, right? So like this first example here, it's increasing from minus 2 to 0, right? Then it's decreasing from 0 to 2, and then it's increasing from 2 to 4, right? This one over here is increasing everywhere. This one over here, it's decreasing at the start all the way till it gets to the origin. It's increasing, and then it's decreasing, and then it's increasing, and then it's increasing. So decreasing and increasing, right? Does that make sense, these words? It's like the common English meaning of decrease and increase. Of course, this one, in the language of the book, is neither increasing nor decreasing. It's constant, right? Okay, so, oh, I haven't had a positive example yet. Do you think this equation defines y as a function of x? I'll write it down. You've got x plus 3y equals to 12. Solve for y. 3y is 12 minus x. Y is 12 minus x divided by 3. Is y a... Yes, y is a function of x. And